Another problem for plane and solid geometry. Find the radius of a circle inscribed in a rhombus whose perimeter is 60 inches and whose longer diagonal is 12 inches. So as I said, we first visualize our given parameters. So we have first a circle inscribed. So you have a rhombus. We know that a rhombus, of course, we need to be familiar with the different polygons, no? So the rhombus example. So this one is a regular rhombus, or maybe not. Sorry, this is not regular. So it's just only a rhombus. And then you have as perimeter. So the perimeter is the sum of the lengths of each side, all the sides of the rhombus, and then it has also the longer diagonal. So we have this is the longer diagonal. This measures 12 inches. Then the perimeter is equal to 60 inches. Okay, so find the radius of a circle. So we know that that our circle, the center of the circle lies in the longer diagonal, and that's then you can construct your circle here. Sorry for that. Maybe we cannot draw a perfect circle here, but for sure, if you say inscribe, so there's a there's a tangent point of this, the side of the rhombus, tangent one point tangent to the circle, or intersecting the circle, and then another one there. So now, having known the perimeter, we know we can determine then the the rhombus is actually, it's like a square, but the same sides, but they just have the different the angle here is not equal to the angle here, but they are supplementary. Okay, so given the perimeter, we can actually get the x, or the length side of the rhombus, which is p divided by 4. So this is 60 divided by 4 is equal to 15 inches. Okay, now you can construct, so you have 15 and you have 12, so you can get something like the 15, then you have 12. Now, and the half of the 12, get and here, then we get this one, and then we get this one, the shorter diagonal. Okay, so our goal is to find the radius of the circle. How to find the radius of the circle? We just simply get this point here. This one is actually perpendicular. So this point tangent to the circle from the side of the rhombus is actually perpendicular to each side, no, and then towards the center. So we can actually draw that one. So we have here, this is now 6 because 12 divided by 2 is 6. Then we don't know this side. Okay, and then we have this. This is the R. This is the one that we're looking for. Now, how do we find R? So given 15 and 6. So first we can determine the theta here. The theta here, so we know that this is angle. So the theta here, theta, can actually solve for theta using since given two sides. Okay, so we can solve for theta by taking the I forgot to take note that this is also perpendicular. So this triangle here, we can solve for theta by 15, 6, and then actually this is a right triangle because the diagonals are perpendicular to each other. So you have 15 and then you have 6. So the angle here, we can solve using cosine. So because this is the hypotenuse, so theta, you can solve theta there. So cosine, we know that cosine theta is equal to 6 over the hypotenuse. So then theta is the, and solve theta. We have 66.42 degrees for our theta. And then to solve for r, very simple. We just draw another so we have this right triangle here, and then you have r, and then you have the half of the longer diagonal 6, and then we now have theta here, which is 66.42 degrees. So therefore r is the opposite, and then 6 is the hypotenuse. So this is actually using sine, so we know sine 66.42 is equal to r over 6. So therefore r is equal to 6 sine 66.42. So then compute this one. So we have here 5.5 inches. So this is our final answer. Okay, so there's no formula that finding directly the radius, but it needs analysis to solve this kind of problem. All right.